Hey everybody, this is Jared with the Enphase training team. Welcome back to another video from our Back to Basics series on our Enphase YouTube channel. Today's session is all going to be around the different communication protocols that we use to get data around from our various devices, as well as up into the cloud. So with that, let's go ahead and jump in and learn about those protocols.
The Enphase products use a few different kinds of communications protocols between devices to move data around. Understanding what these protocols are and how they work within the system is key to a worry-free installation and system reliability. There are 4 communication protocols that are used throughout the products. Some of these have been around since the beginning, and some have been introduced over the years as new products were released. The 4 communication protocols are Powerline Communications, also known as PLC, the Internet Protocol, ZIgbee Wireless, and CANBUS. We'll dive into each of these to explain what they are and how they're used within the Enphase system. Let's start with the Powerline Communications Protocol and learn all about it. Starting off with the Powerline Communications Protocol. What is PLC and how does it work? PLC is just a method of transmitting data over AC electrical lines that are in the house. Instead of using dedicated data cables like Ethernet or fiber optics, we use the same wires that deliver electricity to also carry data. In an Enphase system, we're using this for sending data back and forth between the gateway and the microinverters every 15 minutes. So how do we do this and how does it work? Every 15 minutes, the gateway will send a signal using PLC through the power lines to the microinverters using a specific frequency. This frequency piggybacks on the sine wave and will be different depending on which series of inverter you've used in your installation. For the M-series products, the frequency of 144 kHz is used and transmits that signal using line and neutral. For the IQ series products, we're using 110 kHz and transmits line to line. To sprinkle a little bit of service organization color to this protocol, if you see an error in Enlighten Manager that says microinverter not reporting, that is related to this specific protocol. Pretty neat, right? So now that the gateway has that data, what do we do with it? That's where the next protocol comes into play. The Internet Protocol. You may not know it, but you use the Internet Protocol every day. From surfing the web, or watching the amazing Enphase training videos on YouTube, or streaming your favorite shows from Netflix. All of these things use the Internet Protocol. The Internet Protocol is something that every device that's connected to the Internet uses. Because I love analogies, think of the Internet Protocol like the postal service. Hear me out. Just like your home address tells the post office where to deliver a letter, an IP address tells the Internet where to send data, like websites, videos, or messages. In the case of the gateway, it uses this protocol to transfer data back and forth to the Enphase cloud, also known as Enlighten Manager. The gateway needs to get an IP address so it can send and receive data. So how does it do that? The gateway can get an IP address in a couple of different ways. The first way is from the home's router. The router is the device that provides a different IP address to every device that's connected to it. This is how it knows where to send the data. Connecting the gateway to the router can be either from connecting to the home's router using its Wi-Fi or hardwiring it using an Ethernet cable. The other way the gateway gets an IP address is by using one of the Mobile Connect cell modems. These work just like your cell phone and connect to cell towers. Once the device connects to the cell tower, the cell provider will assign an IP address to the gateway. Another service tip for the Internet Protocol. If you see a status message in Enlighten Manager that says, "Gateway not reporting," this is pertaining to this specific protocol. It's most likely that the gateway has lost its internet connection. The next protocol that I'll dive into is the ZIgbee protocol. This protocol uses the Enphase Comms kit that's used to communicate between the gateway, the system controller, and the IQ battery 3T and 10T. ZIgbee is a wireless communication protocol designed for low power, low data rate communication between devices. It's kind of like Bluetooth or Wi-Fi, but it's made for small devices that don't need to send a lot of data and want to save battery, like in an Enphase system. The last communications protocol that I'm going to talk about is the CANBUS protocol. What is CANBUS? CANBUS stands for Controller Area Network Bus. It's a system that lets all the connected devices talk to each other through just 2 wires. Here's a simplified version of how it works. Using an analogy, of course. Imagine a group chat for your Enphase devices. All of the devices are in the same group chat. Messages have an ID, so each device knows if it should listen. If the message is important, like to go off-grid, it gets priority and goes through first. If two devices try to talk at once, CANBUS sorts it out. Higher priority messages win, and the others wait their turn. This all happens in milliseconds, super fast, super reliable. This protocol is used with the third and fourth generation Enphase system. Pro tip on commissioning. If you're commissioning a system and get to the provisioning step and you have devices that are not being detected, it's most likely the CANBUS protocol where the command and control wire isn't connected correctly. Check your connections for that device and try again. So there you have it. The 4 communications protocols that Enphase uses within the various products: PLC, Internet Protocol, ZIgbee, and CANBUS. Each one works a little different and independent of one another. For more great videos from the Enphase training team, use that Internet Protocol and like and subscribe to the Enphase training channel. See you on the next one.